So we found vast numbers of planets of incredible diversity. But what I really care about is planets that we could send space probes out to and put colonies on and meet aliens and have good science fiction movies on. How we find anything sort of Earth-like mass, liquid water in the habitable zone.
It really seems that everything's against us. We have all these techniques where we find big objects orbiting around, there's, very nearby to to nearby stars. Then we have the ability to directly see things a long ways out. These big 10-size Jupiter mass things that are 100 times the distance from the Earth to the Sun out, orbiting A stars. But we don't seem to have that many objects in that sweet spot of Earth-sized things at Earth distances.
And the best way to find things of roughly Earth-like sizes has been the Kepler mission, so looking for transits. Now remember, what Kepler's doing is it's looking at one patch of the sky over and over and over again. Or for 3 years, it's finished now. And so the typical stars and planets it sees are going to be about 1,000 light years away. And because of the exquisite precision, it can see very small dips. You can only find things close in, because that's where the odds are going to be edge on. But if you have a faint star, a red dwarf star, a close-in thing could still not be too hot. If you put something in, a 30-day orbit around our sun, it would be fried, far hotter than Mercury. But if you have a pathetic little red dwarf, which might only be a few percent as luminous as the sun, maybe these close-in things, if they are of Earth mass, could be right. Yeah. So here is the closest analogue to Earth we've found so far. Now, this is probably going to change by the time you view this. It might well be obsolete, but as the time we record this is accurate.
So it's orbiting a small little star,
yep.
One of the cockroaches of our Milky Way, as we like to say. But those are kind of nice because they last for a long, long time. None of this 10 billion years stuff like our sun. Trillions of years for these
And
things.
it goes around every 57 days. If it was a normal star, like our own sun,
yep.
It would be fried. But because this thing is so pathetic, this actually it gives it about the right temperature. Okay. It's got a radius of 1.33 Earth radii.
So it's a little bit more real estate here than on Earth.
Yep, and we can see these small things most easily about these small stars, because if you remember the size of the dip in the light curve tells you the ratio of the size of the planet and the star. So because the star is small, even a small planet can make quite a big dip.
But we have a problem here, of course, is because this thing isn't a very intrinsically bright object, and so it's pretty faint, and the object's so faint that we can't really collect enough light to really see the reflex motion, the motion of the planet.
Yes, so we can't do the radial velocity technique and find the mass of the stuff. Even if the star was bright enough to do it, these planets is below the threshold of anything we could feasibly see at the moment. It's over 1,000 light years away, so this is not one we're going to be visiting with our space probes anytime soon. The temperature...
minus 27 degrees Celsius. That doesn't seem very warm. It sounds like, why is this habitable? That sounds to me like it's, frozen.
But it turns out that the expected temperature of the Earth, according to the same calculations, is also below zero. The Earth is habitable because we have the greenhouse effect. Natural greenhouse effect, not the human-produced add-on to it, mostly due to water vapor in our atmosphere, and that brings our average temperature up enough that we have liquid water. So it wouldn't take much of a greenhouse effect to bring this up to habitability.
Okay.
But of course we don't know anything about it apart from its radius and its orbit.
So Kepler's found a lot of things. This isn't the only thing. This is probably the best place maybe to look for life yet.
It is a really spectacular one, and probably the best studied one. This is Kepler 62, which has actually 5 different sets of transit dips occurring.
5 little dips, okay. And let's see, we have a very close one in. Presumably that wouldn't be a very nice place, even around a puny little star.
5.7-day period, about 1.3 Earth radii. This one's a very small dip, so I'm not sure we believe this one or not. But it's only 0.54 times the radius of the Earth on a 12-day period. Then an 18-day period, about 2 Earth radii, 122-day period, and 267-day period.
All right, so a real bevy of Earth-like things around here, and even down to Mars and similar types things.
So it turns out in this case it's probably the 2 furthest out that are in the habitable zone. One's right at the close end of the habitable zone, which might make like Venus in our solar system, and one's at the outer edge, which might be a bit more like Mars. They weigh 1.4, radius is 1.4 and 1.6 times the radius of the Earth, which sounds like it could be a rocky planet. But we don't know the mass, we don't know the density.
We don't know the mass and the density, and so we saw when we were able to measure some of these objects that when they're down here, they seem to have that density of not too dissimilar to the Earth, but you do have to worry about maybe these being gas, mini giants. because they just, we don't understand how these things form very well. And so we really do need to try to get a sense of their density.
But once again, this is a long way away. This case is about 1,200 light years away. So it's not something we're going to be sending colony ships to anytime soon.